we are going to understand the Git directory structure. So what exactly it is, like when we are when we are going to transform any of folder into a Git repository, then Git itself create one directory structure which will store all the commit history and all, so that we are going to understand like how internally Git is working by using those files and directories that is being created by Git itself. And this will help us to troubleshoot in case during the project if we miss something or Git is misbehaving. This will help us to troubleshoot. So without wasting of our time, uh, let's look a high level view. So you can see like these are few files and folder Git, Git will create automatically for managing and tracking the changes in the repository. So it'll see mm, same we have already created a repository. This is the Git repository. ABC is the name of the repository. So you can create depends on the organization and the project convention. So you'll see this is the hidden files being was created by Git itself, and you install the Git and create a folder or directory, or transform that folder and directory in a Git repository. So let's see what all folders and files Git itself is created for you. So you'll see like refs, info, hooks, description, branches, config, index, and this one objects, log, commit, edit, and head. So okay, so just quickly for just your understanding and just quickly referring. So where exactly we are, in which branch we are on at any point in time, that you'll see in head file. So how you can check, you'll see where we are right now. Git branch. So the highlighted one is the feature. Okay, so at point in time we are in feature branch. So by now within the repository we are having two branches, master and feature. So at point in time the highlighted one is the, or you can say star is start, like the branch name is highlighted by the star. So you can consider at point in time we are in which branch. So here we are in feature branch. Okay, so if you open the Git head file, right, you'll see where we are in feature branch. Okay, so coming out from the head file, now change the branch. Okay, now I'm going to change the branch. Git checkout master, which this is the command for switching from one branch to another. Sorry. Okay. Okay, since we are in within the folder like .git, that is why git command is not exist, so we have to come out from this and we should continue to work, continue to execute our work within the directory, right, not to .git, not to inside the .git folder. Now check out master. Okay, so it'll see like switch to the branch master. Now it'll see branch. Okay, so the highlighted one is the master. So if you at point in time earlier we were in a feature branch. Now because of you switch branch from feature to master, so at point in time you are in master branch, and the same information is being saved in okay git log one line. Okay, so master and feature has one commit and we are in master, right? So if I in the master, this should be, it should hold. Let me add one file in master like 2.txt. Insert something. I'm going to add. Okay. Now adding, or you'll see like add this file into the repository. Second commit. So this file is you'll see like add is master second commit. Now let me open and you know what exactly is happening, because this is trying to search the head file in abc folder, so but the file is not exist, resulted this is being blank file, it is start. I'll see. Okay, this is something, some permission issue, so you'll see because of we are at point in time in the master branch, so the head file is stored master kind of detail. Okay. Okay, now next index file, like when I'll cover this topic in detail when we will understand the how the data transport from local to working area to the commit area. So these kind of things we will understand in coming sessions. So but for now you just understand when you indexed any of file. For example, if we are creating 123 like kind of 3.txt file, okay, this is a new file we have just created. I'm just saving this file. Okay, so now you'll see if you run this command git, or in fact let me check whether this will work from here. Should be, I believe. Okay, so we are in .git folder itself. Git status. Okay, we have to come out, no way. Status. Okay, going to insert something. Git status. You'll see this is the file which is newly created. So when you run git status clear git status, then you'll see you are running the git status command. Um, then you'll see like how or what files is newly created. So this is the red color, it is being reflected, so you can understand this is the new file. And if you run the add command, so this is something like you are going to add a file in index area. Now you'll see run the status, so you'll see the file is in staging area. So if you check it, you'll check like index, you'll see 1614. Very recently, this file is being created. So it means if I commit back, like this is like 1614, right? Okay, cd dot git. I'm just going to commit -m message, commit message simply. Okay, we'll see dot git folder, then okay 1615. So earlier this was the time when the last time the index file was edited, 1614. Now this is 1615. It means when you add a file, newly added file, that we have to send that file to the stage index area. So once you push the file into the index area by using git add command, at that time this index file temporarily hold the file detail, right? And when you commit the file, the index file again will change because of this file will be release all the references that they captured related to the file, indexed file. Okay, so this is something like, okay, so now so far index file is just to hold the file which is being indexed, or that file is in index area. So this file will be keep updating when you add something in index, or when the file is committed or moving from the index to commit area. So now so far we have had means like this will source exactly in which branch we are, and this is something like index that we, and you'll see one more thing we are going to understand what exactly the commit added message means, what this file is holding. So you'll see this thing. Okay, so again I'll just copy this file, no need to, okay, git log. Okay, so you'll see these many commits so far we have did um, on this ABC repository. First commit something, second commit, and something we add, and then this is the last commit at point in time. We are in the master branch, and this is the commit message. Okay, so if again go to git folder, okay, view and open the file, you'll see this is the commit message. Okay, so the last commit is being held by commit message. Okay, this is the commit message that is being stored in the commit added message file. So 1 2 3 in config, this is a very crucial file. So all the related configurations that we want to configure, like who is committing the code, who is contributing the code, what exactly the name of the committer, what exactly name of email ID of the auditor and committer, and kind of editor that the default Git supposed to use. So all these kind of information, if you open Git configurations, so you'll see this is the something. So far we do not have any configured any username and password. Okay, that is why when we committed the files, you always see something like username and password is not reflecting. So how we can configure? So we are having git config edit. Okay, we'll see because of this is something like the editor, control X. So by using that we can configure, we can add or even the simple way is like git config, sorry, git config user dot name. Here you can put like test. Okay, you can add git config dot email something abc at gmail.com. Okay, so if you want to check something, git config l, then you'll see this is something username and email. So now if you add something and that will be committed, so even I'll 4.txt, this is the file going to insert something now. Okay, new file git add, like index file will be updated, right? So when we are git commit message, we are going to commit message, commit message. Okay, okay, so this is being committed, right? And git log. Okay, so we'll see if you run the git log, then so far till the time we didn't configure our author name and an email ID, you'll see like ubuntu something was mentioned as the author name once we configured who is the author, like it is the test only and this is the mail ID. So is in the git will started using the username and password. So that kind of information is being stored in the config file. Okay, so now cd.git. Okay, so far we have covered index, config, and this one, and the next one is like the description. The description is nothing to make some description or name of the repository, right? So unnamed repository. So um, this is used by Git web application. So about the description kind of you have to mention the Git repository name. So this is all about the descriptions. Now we have few we have few directories, refs, info, hooks, branches, logs, and object. So the object one I'm going to cover. Object one is a very crucial one. Okay, so cd git, we'll see there are a lot of folders are being created along with backend info. So let me jump into the slide to understand more about the object. So we are just focusing about objects folder. Okay. So to understand the object, first of all, we should understand within the object folders, um, like uh, within the object, three type of objects are being stored. The first one is a file in the sense like when we are adding a new file in a repository, that file first encrypted and then compressed. An encrypted compressed file will be uh, will be stored only, and that encrypted file is considered as a blob object. Okay, so once the blob object is created, a hash algorithm is being applied. As such, one algorithm is applied on the blob object for knowing, for getting one um, identifier of the blob object. Okay, that identifier you can the generated identifier will be the 40-bit checksum. Okay, and so let's suppose if in a repository we are going to save 3 files in a single commit. Initially, when we created a directory, we have created 3 files, and all 3 files we are going to save in repository. So 3 blob object will be created. Okay, like blob object 1, blob object 2, respective to file 2, blob object 3, respective to the file 3. Okay. So next, for each blob object has algorithm will be applied, and as a result of applying that algorithm, Git will generate a 40-bit checksum, and that blob file uh, name, further blob file name would be that 40-bit checksum. Instead, out of 40 bits, first 2 bit we consider as a folder name, which you'll see. Uh, um, like you'll see a lot of within the folder, right? You'll be see something. These first two uh, bit of the checksum will be considered as a folder name, and the remaining 38, like for example, if you open this something ls minus ltr, so this is something a file name, right? These are the 38 characters. Okay. Okay, so let me again come to, so like a file encrypted, and that is a blob, and to identify this blob file, if as such a1 algorithm will be applied, this will generate a 40-bit checksum, and that checksum will be considered as the identity of this blob object, and the generated 40-bit checksums amongst first 2 bit will be used for creating a folder, and the remaining 32 bit will be considered as a file name. And now, since you know 3 files, 3 blob object, and 3 um, uh, blob identifier, and these all generated 3 blob identifier in a form of list to be stored somewhere in another object, like blob 1 identifier, blob 2 identifier, blob 3 identifier. So you can consider one more object will be created, and list object will be created, and that list will hold the blob identifier. Like so, for each blob identifier will be stored in a another object. That object called as a tree object. Okay, so again the same, like the list will store the blob identifier and this tree object. Once the tree object will be created, again the algorithm like has a algorithm will be applied, or and this algorithm as a result generate a 40-bit checksum, and this object um, uh, in a form of file will be saved, and one folder will be created, that will be created with first 2 bit of checksum will be the name of the folder, and 32 will be considered as a tree object. Okay, so this is something like the tree object, and this tree object information is you can consider one more object will be created, and this is the commit object you can see, and this commit object will store the identifier, generated identifier of the tree object. Okay, along with tree object, this commit object is also storing the informations like author, time, and kind of author email kind of detail, right? So for every commit, you can see one commit object will be created. So like one folder will be created. Okay, so one tree object will be created, irrespective of files you are going to irrespective of blob object will be created, but only one tree object will be created, and 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 blob object will be one file respective to one object will be created. So here we are going to add 3 files in a repository, so 3 blob object, so it's like 3 folder will be created, and then one folder will be created for storing the tree object detail, and one folder will be created for the commit object stored. So uh, same thing you can understand here. So here in the first commit, let's suppose if we are going to store 3 files, then 3 blob object will be created, and 3 blob object identifier will be stored in the tree object, and then tree object will be stored in the commit object. So likewise, you can consider like a 5 folder will be created in this scenario if we are going to apply. So 3 for the blob object, one for the tree object, one for the commit object. Okay, so you can see like if you are going to add one file mm, in after applying first commit, right? If you are going to add um, another commit or another new file, so you'll see like one file if we are going to add, then one blob object will be created, then that identifier will be stored in a tree object. So the tree object identifier will be stored in the commit object. So like one object, two object, and three objects. So additional 3 folder will be edited. So initially we were having 5 folders, and now total 8 folder will be available. And if another file we are going to add, so another 3 folder will be created. So like 11 folders will be created. Okay, let me see. Let us see the same thing. Okay. Session is expired, so let me reconnect. Okay, this is Ubuntu machine. Let me connect. Okay, we are having ABC directory, right? So just to understand this scenario, I'm going to create another directory in that directory. Mm, transform like XYZ. XYZ directory. We are now XYZ and we are going to transform the directory into the Git repository. Okay. Okay. Git and Git init. This is initialized. Okay. So you'll see. Okay. Object. At point in time, you do not have any of files in that. Okay. Now again, come back repository, which is XYZ working area. Here we are going to add one file, and that one file we are going to add into repository. So let's see how this folder will be changed. bi. Okay, so we are going to create one text file, something something. I'm not just adding git commit, just a dummy message. You can see it's like Chandra. Okay, so you know, one line. Okay, so you just consider this is something uh, the commit. Now, because of one file we have added, so it means okay, like this is the kind of scenario. One file, one blob object will be created, and that blob object will be stored in one folder. The folder name will be the two letter of the checksum created to identify this blob object. 38 character will be considered as a blob file name, right? So one folder, and for every commit one tree object will be created and one commit also. One, two, three folders will be created, should be created. And let's see, uh, objects. So you'll see like these are the three objects. Okay, so the final commit, like you'll see like this is something like fe. So you'll find some fe. So this is, you can consider like the commit object. And a hierarchy, you can consider like the commit object will have tree object, and tree object will have blob object. So likewise this will work. So now we understood about the object folders. Okay, layer dot git ls minus ltr. So now come to log folder, right? So be better to go to abc, where we have lot of commit. So git log one line. Okay, this is something like these many commits we were having. Now cd logs. So this log can store all the commit, like the parent and child commit informations, and the commit message as well. You'll see like head and tag something, uh, ls minus ltr. You'll see one folder like head and reps. If you go to reps, you'll see head, and this will also have the. Okay, so you'll see um, we have two branches, so like two files will be created, and each and every file will have this is the master detail, right? So I'm just going to open, so you'll see like the first commit is like b3, okay, and the last is ec before 36. Okay, so I'm just copying this so that we can easily understand. Okay, so head fetch master because of, okay, all 40-bit checksums will be displayed. Right here you'll see like short message, initial few characters of the commit message. Okay, so first one like the first commit, instead again. Okay, first commit. So this is the first commit, and the user is this one, and this is the parent, and this is the like 9209 something. This is the commit ID, and the next 92 is the parent of this one. This is the second commit. Like the second commit. Second commit is this one, 5f something. So you'll see like the 5f. So this file 5f, and the child is this 29d3, 29d3. Likewise, you can understand the parent, child, user, like author name, author detail, and commit message, and the timing, commit timing, and the parent child information is being logged in that directory. Hope it is clear. So, so we can see like if we need to understand what is the child, what is the parents of any of commit, we can track from here. Yeah. So log folder we understood. Okay. Now log is completed, object is completed. Now we have to like this one, like cd info. Here you can see you'll find one file which is like kind of exclude related information, so like could get ignore kind of files what we are going to exclude, while to making those kind of files to be part of Git repository. That kind of information is being stored in the info. Okay, now next is ref. This is again very crucial, and but Here you'll find the tag and heads. So you'll find like head, you'll find one like two files as like you find it in logs. So this is the latest commit message is being available. So like if you run git log one line, so you'll see the latest commit message is something this one. So if you open the head, within the head you'll find some master, because of we are talking about the master, we are at point in time in the master branch. So you'll see the master, this will save this informations like, okay, master. So you'll see the latest commit is like C24 something something, okay. So and hooks related to if we want to run some customized script along with you can see like Git is providing some script samples, right? If you want to use this script like before commit something to be executed, and this is a sample script that you can add it. And to do this, what you have to do, mm, just to exclude the sample and make this pre-commit file, make sure this is executable. So this is the executable files, and this you can use along with your git command. So this script will execute something if you want to um, displays before the commit and all. So this kind of sample script Git is providing to you that you can refer, you can edit, or you can modify uh, uh, as you wish. So accordingly, as per your need, you can use that one. Okay. So it's like I think I have covered almost also branches is holding the branch related information. So the key thing is like whenever you are the Git is repository is completely depends on the head. So it is picking the head, and obviously you know they explain in which branch. So this is always keeping information is the branch related information, config is the configuration related information. So all the objects in file to be stored in the object file, index is the temporary location which is temporary holding the indexed file, or when you release or commit of changes, and then the file will be changed. Commit edit message, the latest commit message is available in this file. Description just holding holding the repository name, you know, log. You can every log like it's depends of how many branches you have. So every branch respective to every branch one file will be created. That file will store all the informations like what is the parent, what is the child, and who has commit message, and the author detail and all, and info, the exclude related information, and refs folder. You can find the heads and tags related reference detail. So the latest commit is available if you have it depends on the depends on the branches that you have. For example, if you are having two branches, then two file will be created, right? Likewise, and this reference will have the latest commit informations, okay, within the heads. Latest commit information will be stored. So likewise, you can track and And if something is wrong, if Git is not working or accidentally something is being deleted, you can track and easily troubleshoot where and what information is available, and accordingly you can work on. So this is all about the default directory structure or Git directory structure which Git is providing, or